All right. Hello. Hello. Okay, so today I'm going to be talking a little bit, a lot about DevOps. So this is a developer conference, so I don't know how many of you have to do ops very often. So basically what I'm going to be talking about today is I'm going to start by talking kind of in the general sense about what DevOps is and what's been going on with DevOps, and then get a little bit more specific and talk about my tools specifically, but I'll mention some other tools in passing. But the general goal is, I think from maybe like for 4 years, from like 2007 to 2011, give or take a little bit of time, DevOps was really easy. You just had to know like Chef or Puppet or something, and you were done. That's all there was to do, and implement it. But I would say in the past like 3 years, especially the past year, for people who don't do ops or DevOps all the time, it's gotten really, really confusing because there's a lot of different new tools coming out and a lot of different ways to do things. And now, like, it's assumed you use Chef or Puppet now, but there's all these other things. So I constantly see on Twitter and get asked at conferences and meetups and all these things, questions that don't make a lot of sense. There'll be people comparing basically, apples and oranges in terms of DevOps. They'll say, like, should I use Chef or should I use Vagrant? And I'm like, well, those are the okay. So I think these sorts of questions come out of the fact that it's just very confusing right now. So I'm going to try to explain some of this, but also dive in the second half of the talk into more technical things of what's going on. So we're going to have to move a little fast, though, because this talk runs a little long. So that's me. So I have a company, HashiCorp, and we're a DevOps tools company. So what we do is we just try to talk to other companies and see where their pain points are with DevOps and try to build tools to solve those problems, because I believe that good tools can't come out of other companies that are doing other things, because they're not interested in making the tool very good because they're trying to make the business good. So they usually get something that works for them, then release it, and then either don't maintain it very well or just like fix bugs. Where what you really want is something to grow and adapt to be useful for everyone. And that's what I'm trying to do while also trying to make money. And it's working so far, but who knows. We have 3 tools, and these are the 3 kind of out right now. I'm going to cover each, so don't worry about that. Okay, so to start, I'm going to start off by talking about the application lifecycle. Like I said, we start general and then get more technical. So the application lifecycle is the process of any application from development to production. And when I break this down, it really breaks down into 3 categories, sometimes, depending on the company, 3 silos. And I'm just going to go in order. So the first one is the development process. So in development, which I also say is the fun part, because nothing really matters that much. You could break things and try new things, and it's fun here. It gets less fun as you go on. But in development, no matter what you're working on, you kind of want 4 different features of a development environment, whether you're using Vagrant or anything else. You kind of just want these 4 things. So for one, you want it to be readily available. So whether you're at work or a cafe or something, or on a plane, or on vacation or something, you want to be able to work on something if you have to. And when I say readily available, I'm not saying it has to be offline, because there's a lot of interesting online IDEs coming out. I'm not saying it has to be offline, but it just has to be accessible. So there's some companies where you could only work on your thing if you're at your work computer, and unless it's the NSA or something, you should be able to pretty much work on it anywhere. Another feature you kind of want is to be able to make changes and see the effects of those changes as quickly as possible. So the golden circle that every development tries to reach is this thing where you code, you save, and then you reload the web page or anything, and you see the difference. And sometimes you can't achieve this, but everything tries to head in this direction. And not just websites, which is PHP got this really right. This is one of the only good things about PHP. But even with, there was like a Ruby Motion talk earlier, and you want this sort of, like, it would be great if you could do this with an iOS app, right? Because if you use iOS with just Xcode, you have to save something, compile, it sends stuff down to the phone, which takes forever for some reason, and then it starts. And then with Ruby Motion, you just run rake, and it's a lot faster. Like, you get closer to this. So you really want to head in this direction. You want consistency, and by consistency, I mean avoiding what's happening in this comic. So you want the development environment to work the same on everyone's computer, and ideally you want people to be able to use any sort of operating system, but that's kind of just a cherry on top. But basically, when you have this problem, it really sucks because you don't know whose fault it is. When something doesn't work on someone's machine and works on the other person's machine, you're not quite sure if the other, like, whose machine's broken. You don't know. And so you end up you end up wasting time of at least 2 people for some amount of time to fix it. And that should just never happen. And then, to some extent, you want collaboration and sharing features. So while programming mostly is like a solitary task, unless you're like pair programming, at certain points, at least I would say once a week or more, you want to be able to show people what you're working on or get help from someone or something. So you want some level of collaboration. And then just a review slide. But yeah, no matter if you're working on web apps, desktop apps, iPhone apps, you want these sorts of things. And then going down, the next one is deployment. So once you're done with the development part, that app needs to get to wherever it's going to run somehow. And for this talk, it doesn't matter if it's going to a test environment or staging or production. I'm just talking in general about deployment. It's just got to go from your computer to some usable, like real world environment somehow. And this could kind of break down into 2 separate categories on its own. So you have the part where you have to start and configure servers. So you need to run a server somewhere, or needs to get running somehow. Some software then needs to be installed on it, and then the software needs to be configured to be able to run your application. So that's the first phase of it. And that's, I'm sure everyone's seen this picture now, but that's Google's data center, which is super cool. And then you want to deploy and run your application. So once the servers are up, that's usually a separate task, even though they're all part of the same goal of deployment. Someone else starts the servers, but then someone else wants to be able to deploy and run applications, which has a few steps. There might be a compilation step, Java or something. You want to get it on the server somehow, deliver it on there. You want to start it and verify it's running, and then hopefully it's a separate step, but sometimes the same step. And if it's PHP, they're all the same step. But you hopefully have another separate step that makes it active. So you want it to start, and then you want to make sure it's okay somehow, and then you want people to actually go to it. But this is kind of the things you want in the deploy phase. Deploy phase is really funny because it's really easy to say what the problems are or the goals are of the deployment, but it's actually really hard to solve these problems. It's very rare to enter any company where they're super happy with both of these systems. Unless it's PHP, they're just like, we just FTP it up. It just works. Deployed. I don't mean to make fun of PHP. It's just so easy. And the last kind of phase, after you deploy it goes into maintenance mode. And like I said, it gets less and less fun. So now we're at the part that's probably the least fun for most people. And so maintenance is really about keeping everything running while also changing everything, which are kind of 2 opposite things, because the easiest way to not break things or keep things running is to just never change them, but that's not what the businessman wants. So for maintenance, there's just a few things you need. Monitoring. Monitoring's pretty much about anticipating problems, reacting to problems before they're really problems, but when things go red, to know what's going red. You want to be able to update things, so not just updating, again, 2 things. So the ops people want to be able to update software and update servers and security patches and distros once in a while. And the application people want to update applications. So you got to be able to do both. And then there's orchestrating. So orchestrating is a really overloaded word. It could mean a lot of things. And what I mean by orchestrating is you want some way of inspecting your cluster and saying, like, is the average web load below X? And if it's not, then increase the capacity somehow. wait for those to go online, and put them in a load balancer. And this is orchestration because it needs like a full view of your infrastructure. It needs to be able to interact with multiple servers like in lockstep and eventually, have some goal. And usually this is like humans doing this, but again, this is general. So in general, for the maintenance thing, you want these three goals. And so those are the three steps, kind of. And what I call, and this will come up a few times in this talk, but this slide is basically what I call the application lifecycle. And every single application follows this lifecycle. It doesn't matter if it's going to Heroku. It doesn't matter if it's going to a Windows computer as a desktop thing. Everything has to hit these points usually at some point. Yeah, this. So, yeah, if it's Heroku, for example, it just gets rid of maintenance and deployment. Heroku just chooses to control those for you, and you still have development problems. But if you're running your own servers, you have all these problems, and so on. And so this leads to DevOps, finally. And there's tons of talks on DevOps, and this isn't a talk on what is DevOps, not. But every talk will mention that DevOps is mostly a cultural thing, and that's probably true. But I'm mostly on the technical side, so I'm going to only talk about the technical things. So what I say here, don't ignore the fact that there's some cultural component that I'm not even going to talk about. But on the pragmatic goal of DevOps, like the actual goal of it, no matter what it is just to make that application lifecycle I talked about more efficient. People could say a lot of things. It's about people being happier. It's about people working together. It's about all this stuff. The reason DevOps is popular or works is because it makes developers happier because they get their changes out faster. It makes ops people happier because they feel safer doing that sort of thing, and they're talking to people. And it makes business people happier because they think if they're deploying faster that they'll make money faster. So because everyone's happier, DevOps is this huge buzzword. And really the goal is just to make that thing more efficient. And it's a good thing. So how does DevOps how do you make something more efficient? And the answer is tools, of course. And that's kind of a very human answer. I mean, that's what people do, is they do something okay, but in a kind of ghetto way, and then they learn how to make a tool to do it a little better, and then they improve the tools till eventually we master it. So these tools we make for DevOps are real important. So what tools do is reduce human error, because we're not perfect, and no matter what we do, we're going to make a mistake at some point. So remove the human element and make it consistent, which consistency, repeatability, so you're able to do things over and over. And the most important thing, though, that a tool does is this codification of knowledge. And basically what that means is that when you build a tool, you actually remove the need for people to know how that tool works. So, for example, the first talk today was about a bunch of old computers that were older than me. But as an example, way back whenever, to know how to program, you had to know, assembly language. You had to really know how computers worked in terms of registers and cycles and clock speeds and how fast each instruction took and memory alignment and all that stuff. You had to know all that to write a program. And then compilers came out, which were a tool, and compilers got better to the point where Ruby, Python, you don't even optimize cache lines anymore. Most people don't even think about those sorts of things because you don't have to, because it works well enough. It's the same way with any tool. So the idea of a tool is you build something and people don't need to learn what's underneath it because it'll just work. And that's actually, it's not a bad thing. It doesn't make people dumber. It actually makes us smarter, because then those people are able to focus their mental effort and all their knowledge gaining efforts on making things better above it. And then suddenly you have another tool and you get rid of more knowledge. So tools codify knowledge. And so that's two things. You don't need to learn it anymore. But if you do need to learn it, it's in code, which is the most verbose thing ever. So you can know exactly how it works. So coming back to this, DevOps tool is going to solve one or more of these bullet points and span one or more of these columns. And so if you take a look at any tool, they're usually specialized to one thing. There's a lot of monitoring tools, there's some deployment tools, there's development tools. And the whole idea is that you need more than a hammer to build a house. So if each of those tools is a hammer that could hammer a nail, You can't build a whole house with just a hammer and nail. Like maybe someone can. I'm sure someone can, but most people can't. So you need to use these tools together in order to best optimize that whole cycle. And it is true that sometimes the tools are ambiguous. Sometimes you're not quite sure where they fit in there because they seem to solve multiple problems. And that's actually okay. I mean, that's totally okay. And there are a lot of tools that, like a Swiss Army knife, do a lot of things pretty well. So you just got to know that. Okay, so now let's get more technical. I went through that really fast, which I'm really happy about because the technical stuff takes longer. And let's just do a tour of tools. But that's not really true because the tour of tools is really going to be a tour of my tools. But I try to mention some other tools where possible. I'm not trying to pretend that only mine exists. So we're going to go in order in this thing from left to right. So we'll just start with development, just because it makes things easy. And I think most of you probably know development is pretty much synonymous with me for Vagrant. If you don't know what Vagrant is, you can learn about it at this website. But I'm going to pretty much skip all the what is Vagrant thing because it's over 4 years old now, and I think I've graduated from that talk. So the basic idea, though, of Vagrant, the general idea is that when you integrate Vagrant into your environment, anyone in your company is able to clone out any project. Doesn't matter if it's a PHP project, a .NET project, anything. Like any sort of project, any technology, run Vagrant up, and then have all the tools they need to work. That's the idea. And that works pretty well. So going back to those 4 things you want in a development environment, the 4 traits, the way Vagrant hits those is, first, being readily available. Vagrant works with VirtualBox, VMware, and as of last night, Hyper-V. But because it works with these local virtualization tools, VirtualBox and VMware, which run on any platform, Linux, Mac, and Windows, Hyper-V on Windows. But because it's virtualization, it's available on any laptop that has this software installed, which is pretty available. But also, more and more, Vagrant's starting to work better and better with cloud services as well. So AWS, DigitalOcean, OpenStack, some other stuff. Azure once Microsoft signs off legally. But yeah. And this is readily available in that you need an internet connection, but then it's accessible as long as you have one. The second sort of feature was you want to make and be able to see changes. So the way Vagrant does this is it separates the concept of the host machine, which is the machine running Vagrant, and the guest machine, which is the machine managed by Vagrant. And that might be a virtual machine, or it might be like an AWS instance. But those are the 2 terms we use, host and guest. And Vagrant uses some technology to create a sync that's usually bidirectional, but a sync between the 2 machines. And it does this automatically. So you don't have to tell it which one you want usually. It'll choose what it could do. So it tries virtual machine shared folders like VirtualBox or VMware's, NFS if you're on a Linux computer, SMB if you're on Windows, it'll actually use SMB, and then rsync if you must, usually like cloud environments. And actually this is what allows you, this is what's really important, what allows Vagrant to get close to that code save reload cycle, because you still code on your machine using whatever IDE editor you're comfortable with. You save, it appears reasonably fast, like definitely less than a second, but usually milliseconds to the guest machine, and then it picks up the changes and you could hopefully reload and see them. As for consistency, Vagrant works equally well on Windows, Mac, and Linux. So this is really nice because companies don't have to enforce employees anymore to use a certain operating system as their work operating system. So you don't need to join a company and get a Mac handed to you and have to use it. Linux people are usually the people who are really religious about not touching anything else. So now you can make them pretty happy by having them run virtual machines with anything else underneath. But there's also some people that are surprisingly good at Windows, which is rare. So instead of forcing them to learn Mac, which they'll be pretty slow at, you could just let them keep using Windows. And you want your environment shareable. So these are actually new features that I kind of announced or blogged about or whatever last week. But the next version of Vagrant has these, and it's called Vagrant Share and Vagrant Connect. And these make your Vagrant environment shareable. So you could run Vagrant Share at any point. You have a virtual machine, and it'll actually create a name URL thing that makes your virtual machine addressable from any computer in the world that's connected to the internet. So as an example, if you go to this on your phone or your computer or whatever right now, it should load a web page, and that web page is actually being served by VirtualBox on my computer right now. That's assuming my computer didn't sleep or something, but I think it worked. And then the flip side, there's a new command called Vagrant Connect. And if you had the new version of Vagrant, which hopefully you don't, because this would be disruptive, you could run Vagrant Connect and then this thing, and it'll actually give you an IP that acts like it's on your local network, but every port maps to that virtual machine. So that would be fun. But hopefully no one's like SSHing into my computer right now. Yeah, I'll just let you try that if you want. And all the details about this thing are online right now, but not released. Soon. So the idea behind Vagrant, though, is that it's a technology-agnostic development environment, creates technology-agnostic development environments that share a common workflow. So Vagrant's goal, or it's not in Vagrant's best interest to tie you into any sort of technology, whether, again, like it's PHP or Java or Ruby or what have you. Vagrant's real benefit is that no matter what technology it is, it's Vagrant up to start it, Vagrant SSH to access it, Vagrant destroy to end it. Like, it's the common workflow. So we do our best to support any sort of technologies that happen. And there's a Docker talk happening right now somewhere. And for example, Vagrant right now supports Docker reasonably well, and we have other stuff coming that makes it support it really well. But if you don't want to use containers and they're using like Windows, for example, as a virtual machine, that works too. Yep. This. And Vagrant today is pretty popular, so I have this slide. I probably shouldn't have even included it. This slide's actually from 2 years ago, so I haven't updated in the company. There's a lot more now that use it. Usually when people ask me, they ask me who's using Vagrant, and I tell them to list their 5 favorite websites that aren't obscure, like aren't really obscure. And in general, of the 5, I could say 3 are using it, which is pretty cool nowadays, in general. So that's development. There's really no other option for development right now. The other option is install things on your own computer, XAMPP, I guess, if you're in the PHP stack. And that's kind of it. So Vagrant's biggest competition is trying to convince people to not install things on their own computer anymore because it's not too repeatable. And then now let's just head on to the deployment side. So like I said, deployment's really complicated, so I'm just going to cover one aspect of it. And to do that, I'm going to talk about Packer and explain what Packer is, which is a pretty ops-specific thing. But deployment's really complicated. So it has, here's like 6 things that are in the deployment space. And if someone locked me in a room and made me, I could probably list 50, but 6 will work. So, and again, I said there's 2 categories. So there's starting and configuring servers, and then there's like deploying and running software. And you can see that there's like overlap in those 2 things. So it's really complicated. But I'm going to talk about Packer, which is in the start configure servers part of deployment. So what Packer does, and again, this is a really ops heavy thing. So I think you guys might not really care as developers, but it's interesting. So what Packer does is optimizes the slow parts of setting up a server by pre-building an image for it. And images kind of have this negative stigma associated with them. It's kind of starting to go away, which is really nice. But DevOps historically has been against images. So the DevOps way of doing things for the past like 5 years has been to just install Ubuntu, like fresh install of Ubuntu, then install Chef or Puppet on top of it, and do that for every server, and then let Chef and Puppet mold it into what it's supposed to be. And that's what they've said. But it's important to understand like why they said this. So historically, if you go back like 10 years, images were pretty much the only way that servers were deployed in a large environment. If most small websites just managed like one server and kept it working, but if you had a large environment, images were pretty much the only way it was done. And the way that would work is you would have the ops people somewhere in some dark corner of the office, and they would do things, and then they would stamp off the server image for like the business quarter, and they would call it the golden image because that one is gold and it's not changing because it's too risky, and they would lock it off usually for a business quarter because that's what you want to make sure things are working for the whole quarter. And this is really frustrating for everyone. So ops people can't get much improvements into the server because they're not going to change it for at least 3 months. Developers, obviously they're deploying during this time once in a while, but they can't get big changes in because it might have new dependencies or might need configuration changes, and the ops people won't do that for you. So everyone gets a little bit frustrated, and so it was easy as modern configuration management came into play, like 2006-ish, it became easy to simply pretend that images didn't exist. So that made sense. So what ended up happening at these organizations was you would have these shadow ops people that started using this sort of stuff that threw away images, and it eventually took over because it allowed people to iterate much faster, and it was a better option, honestly. But the problem is, by doing that, we also threw away all the benefits that came with server images. There are a lot of negatives, but there were a lot of benefits, and we lost everything by giving it up. And so Packer's goal is really to bring back the benefits while not throwing away the modern changes so that images don't become that same problem anymore. Some of the benefits, though, are super fast infrastructure deployment. So I'm sure most of you have either done a Vagrant up or run Chef or Puppet probably to set up like an AWS instance where pretty simple, maybe just deploying a Rails app or something, but running that Chef run maybe took 10 or 30 minutes just till you got a server. And with images, it's just as fast as Amazon could boot it, pretty much. So everything deploys in like minutes. So all for example, the Vagrant share infrastructure that's running that sort of thing kind of just auto scales out in minutes because they're all image based. And more importantly, I would say is stability and testability. So I think I have slides. Yeah. So an analogy I make for stability and testability of images for developers is that ops without machine images is kind of like applications without binaries. So with applications, you have a source code, you compile it, it becomes a binary, and the source code usually depends on a bunch of libraries. And if one of those library changes, then the compile usually fails as well. But it's usually not an issue because once you have the binary, it's all linked up. So it just keeps working. And servers never had this concept, or they did, but then they lost this concept. So without Packer, without images, you'd have a new server, you run Chef or Puppet, and then the server's ready. And Chef and Puppet depend on a bunch of things like packages existing, the network being really available, and any changes to the Chef or Puppet code itself. And if any of these changes, it usually results in the server setup totally failing. And so by building a machine image, you're kind of protecting yourself against this in a lot of ways. For the most part, when you have a machine image, things work. Machine images are usually more reliable with less reliable networks, for example, and they already have all their packages and everything installed. So the part that's slow about Chef and Puppet is really compiling software, bringing down packages, and doing this over and over again. Like if all this was done for Chef run or Puppet run, it would be really fast. Chef and Puppet themselves aren't inherently that slow. It's really what they're doing that's much slower. So what Packer does is try to get rid of these common things that happen on every single run and just do it for you. So again, without Packer, you get this sort of thing. And then with Packer, it's quite simple. And I already talked about this, and I want to go faster. So the basic way it works, though, with Packer is ops people work on something. They run a Packer build. This sets up users, installs software, and configures it. And then they have an image. The only difference between traditional ops environments is you can't do any sort of orchestration at this level. So the best example to use is if you're building a load balancer. the load balancer at this point can't find the web servers because that load balancer image might be launched 3 months from now, and all the web servers might be different. So it can't do that sort of thing, but it can do everything else. And that sort of thing is usually much, much faster anyway. So you have a couple options there. You can still run Chef or Puppet again after the image is already built, and it'll be a much faster run. Or you could use something like Serf, which is part of the reason we built it. And I'll talk about that next. And again, Puppet, like Vagrant, is a technology-agnostic tool. So Packer, like Vagrant. So Packer integrates with as many people as it can to build images. So here's the things it could build images for already. And there are more than that, OpenStack and some other things in there. And to install software, it could use these things. So its interest is in building images as best as it can for you without, again, imposing you on a technology. And it's doing super well. I don't want to say because I'm on camera, but big websites are using it. And I don't have permission to say, so. Okay, so now the maintenance phase. Maintenance is the most convoluted. So there's a lot of things in maintenance, and again, I think this is 9, and I could probably list 100 of these ones, but there's a lot of things doing for a lot of different purposes, but they all have a really common goal. If you look at these, the goal of any monitoring or any, what else is in here? Deployment or container solution or anything is really to allow you to change things with a resiliency to failure. So being able to handle if something goes wrong or anticipate something is going wrong. It's all just about changing things. So the one thing I want to talk about for this is Serf, because Serf kind of is built on the idea that you could change things and react to changes really quickly and failures really quickly without causing problems. So the one sentence description of Serf is this, and I'll just let you read it because I say this sentence a lot and it's just a lot of words. Yeah, it's a lot of buzzwords, but there's evidence to back all of them, but still it doesn't matter because everyone who reads that just is super confused and doesn't know what's going on. So it doesn't matter how smart you are. Most people are really confused. So the basics behind it, the basic thing it does is manage membership. That's all it does. So it tells you when something joins a cluster, leaves, fails, and so on. And it's funny because a lot of ops problems actually just boil down to membership. So as an example, the easiest example, the most obvious example is a load balancer. A load balancer needs to know about web servers. So for example, how does the load balancer find out if you want to take a web server out of rotation? Of course, if a web server fails, load balancers have health checks, so it'll just disappear. But I'm saying if you want to perform maintenance on this node and you want to gracefully remove it out, you could either manually remove it out of the load balancer. You could just kill it because the load balancer will figure it out, but then you'll kill any connections it has. Or you run Chef or Puppet in some way. But the problem is Chef or Puppet usually run on like 30-minute cycles or something thereabouts. So in the best case, it's pretty fast. And in the worst case, you're waiting around an hour for these changes to propagate, and it's not worth it. You'd probably just kill it. So how does this happen? And on the flip side, if you add a server, how does the load balancer learn about this server? So Serf is one way to do it. So the way Serf works is you run an agent on every node, or on the nodes you care about. You register a handler. The handler could be anything a shell can execute, so I just use a shell script as an example. And the handler actually does the business logic, such as adding or removing a node from a load balancer. And Serf will then invoke that handler for any sort of membership changes it detects. And it detects these membership changes really, really fast, really fast. So I'll get to the speed part later, but basically when people join or leave and so on. So in the load balancer example, it'll be notified that a member is leaving, and it could gracefully pull them out. It could be notified a member just joined, and it could add it to the load balancer. And it also failure checks, too. It does health checks on the nodes. So how does this work? What does it do to do this in a novel way? So Serf communicates completely using a gossip-based protocol. So it's no master. The agent runs on everything. There's no central server. You could kill any number of the gossip pool, and it'll still be fine. And for those who don't know what gossip-based protocols are, the best example, and I love explaining it, is zombie apocalypses. So if there was a zombie apocalypse happening in Linz right now, we would probably find out because someone would hysterically run into this room and tell us, and then our immediate reaction would probably be to tell more people by family or something, calling people, run and do that too. And those people would tell people and so on. Eventually, somehow, really quickly, I bet you really quickly, the whole world would figure out. Twitter and stuff, Twitter's gossipy. And that's the same way with computers. So with a gossip protocol, one server tells another server something, and that server chooses some other servers to tell, and they choose some other servers, and eventually everyone finds out. And that's a really unscientific way to explain it, and there's actually a lot more sane like science and math behind it to make it so it's not crazy and random. But this is actually really fast and really efficient. So one of the biggest people running a Serf cluster that I know of right now runs a 4100 node Serf cluster in AWS. And when they add a new node to this 4100 node cluster, everyone knows within 200 milliseconds without any failures. And in the worst case, mathematically at least, in the worst case, if there's 10% packet loss, which is outrageous, but if there's 10% packet loss on those links, then they'll find out in a second, says the math. But yeah, usually the Amazon networks are okay, and 200 milliseconds for any changes, which is really cool. A lot faster than a 30-minute chef run or something. Then there's failure detection. So built on top of this gossip pool, Serf does failure detection. So the way this works is again somewhat novel. It's not stupid. There's a lot of stupid ways to do failure detection, and the most common one is heartbeats. So most people do failure detection by saying, I know about you, so to make sure you're alive, I'm just going to ask you if you're alive every so often. And everyone does that, and the problem with everyone doing that is for every node you add, you exponentially increase the number of connections and like heartbeats that are happening, so your bandwidth, as your nodes scales linearly, your bandwidth scales exponentially, and it's not scalable. So Serf, on the other hand, uses a linear approach to failure detection, and I'll just start with the bandwidth. So the bandwidth that 4100 cluster uses, 4100 node cluster uses at all times is around a constant, I think it's like 700 kilobits per second. So it doesn't even show up on a network graph. You won't even know it's happening, but that's the communication, and it scales linearly. So the way the failure detection works in Serf is, again, a very human way of doing it. It does heartbeat, but it heartbeats by relying on probabilities. So instead of heartbeating everyone, every second, Serf will just choose a random person it knows about. So the 4100 node cluster will just choose one out of 4100 and ask that person if they're alive. And the way probability works is if all 4100 just choose one random person, then hopefully you just hit everyone. And that turns out to mostly be the case, at least, especially if you're doing it every second. Then every few seconds you're hitting everyone. And then when it asks them if they're okay, if they don't respond, it's very protective of failures, because failures are usually kind of annoying to deal with. So instead of just reporting that person's dead, it then asks 3 other random people, have you heard from this person lately? Because maybe I just can't talk to him. And the 3 people, if they say no, then it uses the gossip and tells everyone, I suspect that this person is dead. And then that last suspicion, it's actually called a suspicion packet, that last packet, gives the suspected person a chance, if they're alive, to send back a message to the cluster and say, like, no, I'm definitely alive. That's good. And finally, if that fails, then he's marked dead. So that's a lot of communication happening. But again, it's reasonably fast. So in that big cluster, 4100 nodes, the failure, detecting a node failing takes about a second for all that communication to happen. And that's pretty good. And you could tune all those things. Like if you don't want to ask the 3 people if they've talked to that someone recently, then you could just turn that off and you'll get failure detection in like 100 milliseconds or whatever. And then the coolest thing is we've built this layer that allows people to gossip already, so why don't we just expose it to people? And that's what we do. So with Serf, you're able to just say, send this data through the gossip cluster, and we'll communicate it for you. And so these custom events, as they're called, are really useful because in that load balancer example, you could send a custom event that's saying web 36 is going to go down in 30 minutes. So the load balancer could get that gossip thing. You could send that message on anyone, and the load balancer will get it eventually and be able to gracefully pull them out before that 30 minutes is up. Yeah, neat. So a lot of people are using Serf to do things like kick off Chef and Puppet runs. Instead of running Chef or Puppet every 30 minutes, they don't run it at all until they make a change to Chef or Puppet, and then they use Serf to send out a message that's like, okay, you guys should all run Chef now because I changed it. Or deploys. They're using it for deploys and other stuff. So what it looks like is, I'm running out of time, so you run the agent, you join a node, and to join, because of the gossip thing, you only need to know one IP. And a lot of people ask, how do you figure out that chicken egg problem of that first IP? And I'm running out of time, so I don't want to go into detail, but use the DNS server. That it knows everyone. But the result of Serf, what makes it valuable, is because you engineer all your software to know when people come and go within like sub-second notification times, you actually make it really resilient to failure. So if this was like a 50-minute talk or something, I would show you an example where I bring up a cluster of 150 AWS nodes that are load balanced, and then I could show you them load balancing, and then I could just like choose, however many you want, and then just kill them, and they disappear from the load balancer within before you could even refresh the page. They're already gone. But because every app knows that's going to happen, then they're engineered that way. Yeah, it doesn't matter for right now. Okay, so now let's just skip that. So the whole, So the whole topic, I guess, of this talk was DevOps moves really fast. Like Packer and Serf, and let's just throw in another one that's not mine, Docker. All three of those things did not exist 9 months ago. Right? That's weird. And really big companies are adopting all three. And so that's really crazy. And DevOps moves really fast. So it's hard to keep up with this sort of stuff. And so my warning to you is to be aware of lock-in risks, because when things move really fast like this, lock-in is the worst thing you could do. For example, Chef and Puppet are really high lock-in factors, and that's fine. But if you adopted Chef 6 years ago, you're probably still using Chef today because you have millions of lines of Chef cookbooks. And even though something cooler might come out, I'm not saying they are cooler, but say you like Ansible or something, you might play with it and think it's cool, but it's really unlikely that you'll be able to switch to Ansible. It's just not going to happen because it's too expensive and managers will shoot that down. So just be aware of what's happening and lock-in risk and think about it. And my sort of pitch is I personally and from a business perspective, our tools aren't in the best interest of locking you in. So there's that. And my takeaway is that there's a really clear problem set here, and DevOps tools have to solve one or more of these things. So whenever something comes out, which is probably like today, I don't know, something comes out every day. Whenever something comes out, just take a look at this sort of thing and think of where it comes in, and that'll answer your question of, do I need it? What problem does it solve? What tools does it replace or compete with? And so on. And so the final cute analogy is, I like to say, the opening slide. We started with this, and because of tools, and this took 80 years to build or something, and because of tools, we can now build something like this in less than a year. And that's also kind of a grave because it's a museum. So, so thank you. That's it.